For the number of daisies found in 1 meter square of Mears field, if you were to let it be D1, and for 2 meters square, we'll let it be D2. And if the average of the number of daisies found in 1 meter square is lambda, so for 2 meters square, applying the scaling property of Poisson distribution will be 2 lambda. And according to the question, the probability when D1 is less than or equal to 2 is the same as the probability when D2 is bigger than 2, which means that the probability when D1 is less than or equal to 2 is the same as 1 minus the probability when D2 is less than or equal to 2. Because for D2 to be bigger than 2, D2 will be D2 is equal to 3, D2 is equal to 4, and so on. So 1 minus less than or equal to 2, since we want 3 onwards. And to break this up into its component, I can rewrite this as probability when D1 is equal to 0, or when D1 is equal to 1, or when D1 is equal to 2. This will be equal to 1 minus probability when D2 is equal to 0, and minus probability when D2 is equal to 1, and minus away probability when D2 is equal to 2. Then if I were to apply what we have in our formula sheet for the formula for Poisson distribution, this will be e to the power of minus lambda, lambda to the power of 0 divided by 0 factorial, plus this e to the power of minus lambda, lambda to the power of 1 divided by 1 factorial. As for this, e to the power of minus lambda, lambda to the power of 2 divided by 2 factorial is going to be equal to 1 minus this. It will be e to the power of minus 2 lambda, then 2 lambda to the power of 0 divided by 0 factorial, minus this, it will be e to the power of minus 2 lambda, 2 lambda to the power of 1 divided by 1 factorial, minus e to the power of minus 2 lambda, 2 lambda to the power of 2 divided by 2 factorial. And if I were to bring everything over to the left hand side, what I will have is e to the power of minus lambda. If I were to factorize out all e to the power of minus lambda, this will be 1, and then this will be lambda, and here it will be lambda square over 2. Then this, if I were to shift it over to the left hand side and factorizing out e to the power of minus 2 lambda, this will once again be 1, and here is 2 lambda, and this is going to be equal to 2 lambda square. Then 1, bring it over to the left, is minus 1 is equal to 0. If I were to make use of my graphing calculator to solve for this, I'll be able to get the value of lambda, which is what the question wants. So lambda is 1.85.